But what I'm going to focus on is very important concept, which is design. Okay, that is very, very important. If you consider design as an important way of looking at it, I'm going to focus on that part. I assume most of us already know SQL. Okay, that's not, I'm going to talk about third normal form. I'm not going to talk about that at all here. What I'm going to talk about is something which is industry standards. So I'm going to talk about, let's say, start from what are we going to discuss today. We're going to discuss about the industry standard. What are they? Before I start on this, all these things are there here, but I'm going to focus on the industry standards. What are the industry standards? What are the things which are coming up in the industry? How, for example, Microsoft solve these problems, Google solve this problem. So I look at like monkey see, monkey do. That's, if you have seen my, if you have been in previous slides, I look at big companies, how they're solving the problem, and I literally follow that to the dot. Because if you don't do that, you're going to miss out on a lot of those things. What that means is, if you are, anybody here selling a product? Service? You're doing a service or product. Anybody not selling a product? There's nobody here who's not selling a product. You're either doing a service or a product. Yeah? That's what you have got. So I have got both of them covered today. So you're going to go back from now and you're actually going to start using it from slide 1. I can guarantee that. Okay, that's my guarantee. Okay, so let's take it through. So what I'm talking about here is these are all the databases you can think of, like, there's no end to it. Like, you can go till the end. It's not going to end. So this is a half-day workshop, guys. So I don't have the kind of the energy to reduce the slides. So don't mind if I skip up some slides, but that's only for your benefit because I want to make sure important concepts you are in a good shape. Okay, from architecture perspective. So let's take a look at big data. Why I'm talking about big data design pattern? Because we all started from like a relational database. Oracle 78, it came in 78. SQL Server came in around, the Postgres came around, the MySQL came 95. And now we are moving towards more Hadoop or Cassandra or NewSQL, which is coming in. So what's really happening is, if you see what's happening is the number of databases are keeping on increasing here. So number of databases you can see here. See, these are all the number of databases which are there. So if you see here, the document store database is a lot of databases are coming in. White columnar databases are coming in. Relation databases are still big pie. If you say somebody is telling you relation database is going away, that's not true. And I am in proponent of using relational database. So if you're saying that, oh, it's going away, that's not going to happen in near future. Basically, everybody will come back to relational database. I'll talk about that in a second. But if you see here, this graph here, this graph is telling us the graph databases are picking up. See this? Graph databases are picking up from 2013. They are number 1 in the industry. Number 2 is time series. How do you get the time series? Using columnar databases, you get the time series database. But then if you see here, key value database, which is actually and then document DB database are there. Search engines are also there here. So that's what the trend is going on across the board. When this trend is going on, what do we focus on? Which database should we focus on? That's a very tall order to answer the question. Like I say, it depends upon what do you want to use at any given time. So for everything, like for example, this is the link which I have got, DB engines. So if you go to dbengines.com, so I have like exactly all the links which you need to actually click here. I'll add more details when I get a little bit more time. But this is where, if I go back to this here, this gives us all the databases for us. So the important one here are some of the databases we are going to look at. But as you can see, these are like lot of databases. Yeah, spatial databases coming out. Last 1 year to 2 years, spatial databases coming out. That means geospatial coordinates. You need to know where the geospatial coordinates are, so you can now act on top of it. For example, Amazon has Amazon Fresh. Do they have it here? Amazon Fresh? Yeah, so they have it here. So if somebody is asking for a location for Amazon Fresh, they know geolocation coordinate, then they're not going to even offer that there. So that's the way they are controlling the geospatial coordinates. Graph databases are there. So these are all the databases we're going to look at today as part of our journey. So I don't want to spend time here. So let's move on. We'll come back to it, guys, later on. So now if you think about it, I'm going to take a journey with I want to book my flights. I want to book flights going from one place to another place, Boston to Chicago. In this case, I'm going to meet my best friend. He lives in Chicago, so I travel there. So when I'm traveling, what's really happening behind the scene? We are going in and deciding what database do I pick for different scenarios. Whenever I want to pick the database, it depends upon high rate. If there is a high rate, that means millions of requests are coming in. Twitter, millions of requests coming in. What do they need to do? What database they can use? Cache. They cache the data. So they're caching the data for all the timelines, and that's the way they're using it. Now, if there is a high rate is there, but you need to now get the data for all the recommendation for the products. What database to use? In that case, partitioning key. Depending upon the partitioning key, if you have it, then key spaces. You want to put it in the key space to use that database. Or DynamoDB to use that. Now, if you have an object store means the whole object is stored there. For example, movie. You have a movie. Movie is of how long? Like 3 hours movie or 1.5 hour movie is there. That movie what you're going to do is, that movie you're going to chunk the movie out. What are you going to do? You're going to create different chunks and put that chunk in S3 bucket, object store. And then you're going to play that movie. If you see, think about it, what's really happening in the movie area. When you're seeing a movie, if you replay that same movie, it starts little bit, and then it starts like, you kind of like, it starts from the like 15 seconds before. What is that? That's the chunk you're playing. So that's the chunk. You start from wherever it starts, like, till the time it finishes, it keeps the pointer for you, what movie you were watching. The Netflix does that, yeah? So that's the chunk is stored where? In S3 bucket. But the partitioning key for that movie, that means partitions of all those chunks are stored where? In key spaces, in Cassandra database, that for this movie, where are all my partitions? These are the partitions, and then read that partition from there. Make sense? So I will give you exact examples, like not just talk about the database when we are working on it. Third normal form, we are all familiar with it, like kind of a star schema is there. A product has a sale, which has a sales representative, which is using the system. So, and this is a kind of a normalized and unnormalized data of a test score which you are trying to create. The problem with this approach is order line item, product is there. This data is perfectly fine for asset transactions, no doubt about it. But whenever we are trying to show the data to the user from the user from here, what do we need to pick? When some data is coming from here, what do we need to pick? We need to pick cache. That's number one. Number two, what we need to pick? Which system I'm connecting to? I'm connecting to quoting, then order. From order, I'm going to inventory. From inventory, I'm going to billing. From billing, I'm going to activation of the order. If there is a problem, fix that order. And then if there is a fraud, then detect the fraud and tell everybody there is a fraud. So all these things is stored in different databases, guys. So now what happens is, this is what happens. So one thing is, where do you keep customer data? Yeah, you can create a database for one customer. You can say, per customer, I have one database. Amazon does that way. They have one database for everything. That's one way to do that. But you cannot do that for a queue. In a queue, if you're using a queue or using a Kafka stream, you have to use a common database for that. Yeah, common infrastructure to solve that particular problem. So some databases like caches, you're going to keep tenant ID and then their information. Yes, that's one way to solve that problem. Some databases you're going to keep it in the database, which is like MySQL database or Cassandra database and other databases to pick this problem. Yeah, so we will talk about all these today. Okay, so that said, what that really means is, whenever we are creating the data model, see this here. We implement this way. I have done this. I take pride in doing this way. Like, before, like 15 years ago, one application, another application came in, another merger happens, you do point-to-point integration. How many here did that? Point-to-point integration. That's now also it happens. There is another merger happened. Okay, integrate that thing. What we need to do is, we need to create a common data model, which is called as canonical data model. What is it called? Canonical data model. And that is not actual database. Okay, that's one thing very important to understand. But this data model, every other app understands. Make sense? That means canonical data model means you have an order, that order is now to have order line items, and that each order line item has a product. Everybody knows that, yeah? But there is a canonical data model for that. It's better you implement the canonical data model. Make sense? That is, if you do that, now you can plug and play other architectures using the middleware and be able to connect using that. Everybody on the same page? Yes? So what does that mean? I'll show you some of the canonical data models so we are on the same page. One of them is called as a party data model. Anybody know about the party data model? Yeah? Go to a party, yes? So okay, so let's talk about party data model first. So what's really happening, a party can be an organization or a person or a functional group. For a given party, and I'm going to go down here, for a given party, I'm just going to show you one contract, okay? A party can have a contract. A given contract, see this, a given contract is owned by a party, but it has a cost center associated with it. Attachments, you can do it. There are KPIs, there's a time entry for that cost center, yeah? So this becomes our contract as an entity when we are working on it. If you are defining a contract, I suggest you look at this model first. Make sense? That's the database. That's the third normal form you're talking about. What do I do in the third normal form? This is the way you're going to go in and actually use the system. So now you're creating third normal form properly. Okay? I don't want to go over all of them, but you get the idea. Organization is the same thing. Asset. If you're building an asset, what are the assets having? Assets having a cost center, a party, a location. Asset can be a car. You know, car can be an asset. And product model and other details here. This can be your product also. Product is also an asset behind the scene. So this is an asset. What data model to use? This is a data model to use for that. Make sense? So that is one way of understanding the party model. Let me explain you another way to understand the party model. So there is another thing called ARTS. ARTS is also a good tool to use if you are selling any product or service. It's good to use that. So I'm talking all industry standard guys. This is like, if you follow these standards, you will be in a good shape. So for example, I want to drill down into inventory management, or I want to drill down into retail transactions. I want to drill down into retail transactions, how the retail transaction took place. But it can also give you order information. It can also give you other information. You can look into it in more detail, how it is implementing the solution. I'm not here to tell you exactly how it is working, but I'm telling you there are industry standards which does something like this. This is the party model I'm showing you in that industry. If you're using retail, you probably want to look at this when you're building your model. Okay? Now, common information model, I mean, this is something which was used by AWS and others. They're creating that model. If you're hiring, marketing, selling, any products you're using, you can use this. For example, setup, what things are involved. So these are all the objects which you might have in your company right now within this itself, because you're going from setup to analysis. I'll pick only one model, party model. So what party model is saying, and don't see this is very complicated, it's not that complicated. A party can be an organization, an individual, or a household. Yes? Everybody on the same page? This is can be any of these things. This can be a global party. This party can be a role. That means you can be an employee. You can be an employee for your company. You can also be a vendor for your company. Yes? You can also be a seller for your company. You can also have a company attached to your company you're working on. So that is where the party roles comes in, which is an account. You're creating an account for that. Based on that, you are saying that, hey, you contact me using contact point information. What does that mean, contact point information? That means GDPR compliance. What that means that, hey, don't call me with this phone. Only contact with this phone. Where do you keep that information? In contact point information. Via what channel you are trying to make a call with. So that's what it is. Who, why, how, why, and what. This is called as a party model for consent. party privacy consent. You know, if you want to implement, anybody here wants to implement GDPR compliance, you have to implement that. Look at this, yeah? We'll give you a good understanding how to do that. Not only that, if you want to do the CCPA, like, you know, if you're California, you have customers. Virginia, you have customers. Like in US, you have any customer, you have to use this model to really implement the solution, okay? Now, this is another model from Microsoft. Why I'm talking about Microsoft here? Because they are also giving the similar kind of model for us. Let me explain you. So the Microsoft is giving is, which is also called as common data model. Common data model the Microsoft is providing for all the domains. So you may say that, hey, what are the standard entities and what are the standard domains which are there? These are all the standard entities and domains they have got. Let me show you that. Okay, they are actually, I opened them here. So these are all the common entities. Account. How many here have account as an entity? Everybody got, yeah? So if you want to look at an account, how that looks like, you can actually go to the JSON object and look at that account. This is common data model for an account. How the JSON looks like for an account. What are the fields it should have? Standard implementation, yeah? Not only that, you can actually go in to GitHub repository for it. Now this is the GitHub repository. Let me open this up to show you. You can actually, how many here are from banking industry? Banking, yeah? Let's go to banking industry, yeah? And you can help me out, like whether you have these objects or not. Banking industry has a branch, yes? As one of the objects. Collateral, yeah? So let's take a look at some of the things from KYC. Oh, what is KYC? Oh, everybody knows that. Aadhaar card, man. It's like, everybody knows that. But see, what fields to use for this? Is there a standard? Because if the bank merger happens, if the two banks are not using this format, you have a problem. Yes? Everybody agrees? Now I'm giving you a solution. Before you start creating, a product owner comes back, say that, hey, I need to add a nationality or something else. Wait a second. Let me look at it like how the date of birth is there. What exactly is the format used for the date of birth? Let me use exactly this format, and this is the way I want to implement this solution. Okay? So that's what you get from this. Okay? Very simple, very powerful technique I'm telling you, which is which going to make your life much easier. Address, everybody uses addresses. Currency, what kind of currency format you need to have? Awesome. So you get the currency format, all the fields in the ISO format. What currency ISO format do we need to use? Similarly, product information. Yeah. So within 10 minutes, we know exactly what to use. Isn't that cool? Yes? So now I highly suggest for you to go and look at the Microsoft Common Data Model. Yeah? Now it has got sales, service, all the objects for sales, service, supply chain, commerce. You cannot find anything which is not here. That's what I can guarantee that. Like, you know, you might have something unique for your domain. I'm not saying that. But you will be able to use finance and other industry just by using this model. Make sense? Now, what we are doing is we are creating third normal form out of this. We talked about SQL, yeah? SQL. Now let's go a little bit more into that particular model. We all know ETL process. We can create the ETL process. Now we are adding more data to it. When more data comes in, we cannot put this data in the big data model. That's where the problem comes in. Problem is that data addresses petabytes of data. Yeah? How can I store petabytes of data in one machine? Not possible. That was one of the questions asked. Like, you know, I have a bigger database, I can't store it. Sorry, you can't store it. And you should not store it in the beginning itself. Now, MySQL database is there. What's the maximum size of MySQL database? Anyone? Huh? 70 is what I gave, but like it could be like you can stretch it to maybe 100. You can't make it like 1 terabyte. Yes? So that's what the premise was, to give some guidance, like guidelines, like, you know, I talked about before. The reason I said that because some people say I will use MySQL for everything. But how can you use MySQL in that case if you have 200 terabytes of data? How can you do that? Anyone? Easy solution. Anyone? Huh? Shard the database. Database sharding, yeah? You can do the database sharding. Now the India customers are separate. Uber India customers are separate. And Uber customer for Europe are separate. Uber customer for US is separate. They are separate databases. You have to do separate transactions for them. So that's the way everybody does that. Amazon also creates SQL database. They put all their transactions in SQL database. They're not saying don't use that. That's the right thing to do. But you need to pick and choose what to use at any given time. Now what happens is when the velocity comes in, what should I use to calculate stuff while it is happening? What to use in that case? Spark, yeah. You can use Spark or Storm to really calculate while it is in motion. That's why I have a motion here. Now, unstructured, what I'm really interested in, the ambiguity data, 80% this is a fraud. That's what I'm trying to say here. So a variety of data is there, but what I'm looking for is right information for right person at right time. That's what you're all looking for. For your manager, you want to give a dashboard, hey, act on it. That's the main thing which you're trying to provide in the database. So what it means is, from the NoSQL database perspective, now this is all NoSQL, most of the NoSQL database, actually SQL database started you doing that also. I'll explain you that in a second. So Oracle started doing the same thing. So what happens is that there are multi-core, they're in all different places. Oracle started doing the similar thing. So they're also multi-core. In memory you are doing the calculation. Insert only. What is insert only means? If you insert a data, it is insert. If you update a data, it is insert. If you delete a data, it is insert. Behind the scene, you're going to clean up later on, compaction process. So Oracle started copying the same thing by using tens. So that's the reason they're fast. They're always, even if you're doing a delete, they're not really doing the delete. Just like Java, Java garbage collector is there. Similar kind of philosophy you can think about here, where they're cleaning up, doing the compaction, cleaning up the table later on, dereferencing all the things going on after 1 minute. You don't care. You're going to always get the right data. So that is where the industry is moving. They're all converging towards that direction. Make sense? So that's what's happening here in this case. There is a resilient architecture. So you're going to get an interruption, and AWS has the same thing. You get an interruption, they said, go figure yourself. I don't care. Cloud providers are saying it. Your machine is down, you figure it out. Yeah, it will be down. It will be down because it's network. It will be down. You have to take care of it. 20 minutes, you can't even create a ticket. That's the problem with there. So what that means is you don't want to write a SQL like this. I take pride in writing this SQL. I used to feel so proud that I have written so big SQL. I started writing, I used to, I used to say like 28 pages SQL I write at one time. But it was for Oracle, it was doing data cleanup for selective thing which I'm trying to do. It was some mistake happened. We were cleaning up the data while running that query. It took 12 hours to run. But it's not the good thing to do. It's 12 hours to run. So, we were fine doing that because data was so messed up. So that said, so you don't want to run this kind of SQL. That's the reason we are saying database sharding is important. Yeah. So you can do, how many shardings you can do? You can do database sharding like this. Yes. What other way you can do sharding here? Anyone? Come on. What other thing you can do? Control A. So look at this here. This data. Look at this data. This is constant, yes? This is constant data. So what you can do? You can shard vertically also. It's not just horizontal sharding. You can do vertical sharding also, which is actually better to do, because now what you can do is you can cache this data. Wow, you can cache this. Now what's happening is very, very fast. What is changing? How many stocks are there, and what's the price, and what's the last order. These three things will change. That's not a problem. Yeah. You can also remove from here any PII data. If you have a PII data, remove it. Create a vertical shard for it. That's another design pattern in the database. You can create a vertical shard to do that also. Make sense? So there are multiple ways you can shard the data to really help you out. All right. Availability. So you want to build the availability model where CAP theorem everybody knows. Yeah. You can either be CA and AP or CP. How can I do everything at once? That's the question which everybody wants. Your product owner, if you ask the product owner, hey, you pick one, what are they going to say? No, I want all the functionality. I want high available, high partition tolerant and high consistency. You say that, yes? That they don't listen, saying that, hey, this is cap theorem, then I'm not saying that this is physical limitation. How do we fix this problem? We will be discussing that in a second. Let me see if I have it here. Huh? I'm sorry? MongoDB, you can get it in everywhere. Doesn't matter. DynamoDB does the same thing. It's a slider scale. What is slider scale? Slider scale means you want high consistency, you can get it. But not in that case, not high availability right away, because it's going to be slow in writing. MongoDB you can do it, DynamoDB you can do it, Cassandra database you can do it. No problem. It's all possible to do it. But the problem comes is when you are writing and reading the data, it will not be that fast. That's the only thing. It's a slider scale. Like you pick. But we can't tell this to the product owner. They're not going to listen. They want to do all of them together. Yeah. So in that case, what we do is, let me give you the answer. Okay. What you're going to do is you're going to jump from here. See this? You're going to jumping from here to here. We did that, by the way, in many projects. So what I'm doing is I'm jumping from here to here. I'm sending to the Kafka stream. I'm doing the Spark I'm using to bifurcate the data and put it in the Cassandra database in the partition. For the day, for a given day, these are the orders. Yeah, for this customer, customer orders. Yeah, for this given day, this is the customer order is there. Now, if I need to find out, because I know the partition which is there, now I can go and find out 20 orders the customer has. Now I can process them very, very fast. Can I put this in? Can I put this customer order in something like this? JSON blob? Yeah, you can do that. Now what's happening is everything is converging. That means you can do the same thing in Cassandra database, just like MongoDB you can do it. You get the actual object out of it, you work on it and you're done. Now this is 50 millisecond response time, I'm telling you. Absolutely possible. Now you are consistent, highly consistent, and highly partition tolerant also, and highly available. That's the magic, secret sauce which companies are applying nowadays. It's been like 5-6 years they're doing that. Okay. So now what that means is we talked about all these key value stories there. Now people used to think key value store is only key value store. Not really. Okay. Hold on your thought. If I get time, I'll actually give you a demo on that, because it's not true. Key value store is not just key value store, but it is also MongoDB. It's also search. So it's not just that. So everything is changing. Within past 5 years, all these things have changed. So that's the reason. So what that modern application is, 1 million values are there. That means you pick and choose what you want. You want time series, you want graph, you want in memory, you want document, you want key store, you want relation database. Depending upon the frequency of the call, you pick and choose what you want from this. It's like a memory, integration memory which comes in. That's where we need to do integration. How do we integrate between different systems? Abstraction is there. How do we make sure we get a good, faster implementation for us? That's what we'll look at. We'll start with Cassandra. Okay? So let me see what time we have. We got how much time? Half an hour, huh? That's good. Okay, that's more than enough. Yeah, that's good. So in Cassandra database, what we are trying to do is, it's a baby which came from Google, Big Table, and DynamoDB. So whatever thing you are doing in DynamoDB and Big Table, it came from there. Facebook, we created Cassandra database. Basically, Avinash came to Facebook, and that's where it got created. The perspective is who is not using this. Like Apple is using it. It's a linearity, scale up, linearly scale up. All these companies are using it. The main thing is this, cluster ordered key. What that means is you have a table there. You're going to do all those things. You cannot do join. Okay, what you can do? You cannot do join. What that means, you create ascending order or descending order, the table ready to go, so that it becomes like CQRS. CQRS is command query request segregation. That means you're creating a materialized view in Cassandra, guaranteed 50 millisecond response time. But how can you do a join in that case? Rohit, that's a flaw. Yes, there is a flaw in that. What you can do is you can get the data from there. Now you can do a join using Spark. That's the reason we have here data stacks. I'm not from data stack, but I can say that's the advantage of either you don't need to use data stack. You can independently use both of them and then configure it, no problem. But what I mean to say is, when you marry these two guys, that the marriage is made in heaven. Let's call it. It's a Spark and Cassandra working together. You can do joins. That's the reason it's made in heaven. That makes sense? That's what we are doing in this case. So you need to create the correct partitioning size when you're trying to build the solution. Okay? So everything is the same except for you cannot create foreign key or relationships in Cassandra. Everything else is the same. So this is what the slider scale is. If you want to have 1, that means it will return right away. If you want to do all, that means it will go to all the places and then return. The consistency will become like SQL Server and Oracle, but that will not serve the purpose of Cassandra, using Cassandra in that case. Sometime you want more consistency, but what you do is you differentiate the Cassandra into 2 different parts. One cluster, so this is the way I have solved that problem. One cluster for writing the data, one cluster for reading the data. Now you're highly consistent, eventually consistent. That is perfectly the right model. Now you are like, you might not be getting the data really fast. That's the only thing which is there. That's where the slider scale comes in, guys, when we are working on this solution. Okay, it's the same thing. Now one thing I want to cover here is the conceptual data model, which we can use to make the queries very, very fast. That means if you think about Google, YouTube channel or any Instagram, anything, what they are doing is they are having comments, they are having search, they want to do the account, movies are there, videos are there. Now what it means is a video features many actors. An actor appears in many videos. But you're going to say, Rohit, this is like third normal form. Yes, this is awesome. You create the purposeful design where all these purposes are joined together. Now the abstractions is removed. Now you are going to create the ER diagram based on it. Once you have the ER diagram created, you add the application flow to it. Once the application flow is added, now what happens is, now you get the queries which are lightning fast. Okay? Now the queries are created. Now how we are calling it with the queries, we create ER diagram with queries and create logical data diagram. This is kind of, we are creating materialized views. That's what we are trying to do here. So in this one, find comments posted by a video with a known ID shown in the comments first. Now this becomes like an actual query which is going to be very, very fast for us to implement. So that means how we are using the system, have the queries ready to go. So would there be duplicate data? Yeah. And is that okay? Yeah, it's okay, because I mean it's cheap. It's a Cassandra is cheap, so you can have duplicate data without any problem. Now you can use it in sensor data and all these data you can use it. One important concept to understand is you need to pick the partitioning key really, really well. If you don't pick the partitioning key really well, you will be in trouble. That means you will go back to using SQL Server. If the partitioning key is not correct, it's not going to work. What that means is a network has many sensors. So in that case, what happens, you can do the heat map, you can find the information about all the networks by ascending order. All these queries are there. Now you come up with the logical data model. When you come with the logical data model, then look at each of them and then see that, hey, this network is a small partition size and so much partitions is there. Now, because there is a small partition size is there, the network has it. How about we put all the network in one area? You're putting it in one area. Let's say, one city. You're putting all the city network in one area. That becomes a right amount of size. 100 networks are there. Yeah, that's one thing you have to do. That's why you're creating a bucket out of it. Temperature by network. This is another thing. 1,000 sensors per network. 24 hours you are trying to get the values. Now what happened here? This is a lot of data. 8,765,000 large partition. Reduce the partition. How do we reduce the partition? By adding consolidating that partition. So we can do weekly partition. And that's what happens, weekly sales. Manager is only interested in what? Weekly sales. They are not interested in daily sales. How the projection looks like based on the weekly sale. They have a weekly target, weekly sales. That's the reason they have a partitioning size. The reports when you create, they're weekly reports. So you can create the partitioning size, which is a chunk size to work with. Make sense? So that's what we are doing here in this case. Let's talk about Redis. So Redis is a key value pair, yeah? That's what we call it as Redis. But Redis is not only that. Nowadays, Redis you can use to do session store, we all know that, but you can also do chat apps, chat applications, message queues, PubSub, you can do PubSub with that. You can also do, gaming leaderboards. Why this is very important, gaming leaderboard, anyone? Huh? It's a very hard problem to solve, and they solved it. That's the reason. But you have a good point. Like it processes fast. What it is doing is it's a very hard problem to solve. Let me explain you. The problem that I'm trying to solve is that hey, I want to make sure whenever I increment a number here, I'm incrementing a number here. That need to be propagated to all the servers at the same time, just like a bid system. Somebody is doing a bid. That bid has to be incremented. And that incrementing of the bid you can do using cache, because it will be much, much faster. That's the way you get the real benefit of it. That's the reason, any of the incremental counters, you're going to use this tool. Very, 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 very fast. Microsecond response time. So what's happening is microsecond is new millisecond. Just say it with me. Microsecond is new millisecond. So 250 millisecond I was saying, now say 250 microsecond. How can we solve that problem? It's very tall order to solve. But once you solve that, that takes care of a lot of the problems. So why I'm talking about all these things is because 100 millisecond delay in a website, conversion rate reduced by 7%. Now this you show to your manager. For the technical that you're working on, they will give you, okay, yeah, this is not from me, this is from Akamai. Akamai is telling the right thing, yeah? So what that means is now you know your comparison wise, like what is the best thing to use. So you can have like, Elastic Cache, Memcache you can use for smaller things, but you're going to use Redis for most of the other things. Like, if you have a hash table and other things, you're going to use this one for this purpose. That means any gaming solution you want to create, you can use this. Okay, so let's talk about this in a second. So what really means is, so let me show you the Redis here. So in Redis, what you can do is, this is my Redis cluster, which is running online. So you can actually sign up for this cluster also. By the way, you can get one database free of cost. So what's really happening is, so let me go and first create the query. Okay, so let me go to the database first. Again, I have to reconnect because this is an online connection I'm trying to create. Request timeout. Okay, interesting. That's what happens. So what you need to do is Redis cluster, you have to get like this. So Redis inside is a tool. You deploy it in the cloud and then you start using it. So I'm going to go into this Redis cluster. Now it's connecting. Now hopefully I should be able to connect. Oh, internet is not working here, man. What happened? Let's connect. Oh, is internet working? It's not working? Sorry guys, I would have shown you this because the internet should work. Like ideally it should, but it's not showing me any of the internet here. That's called double happiness. Sometimes it happens. It is not working? Okay, good. Double happiness. That's nothing wrong in that. So we will come back to it, later on. But I'm going to just talk to you about it because there's something good to understand. What I'm trying to do here is you can do JSON. So I'm going to go back again here. So what you can do is you can create a JSON object. The whole object, the whole object you can put it here. Now when the whole object is there, the blob of the whole JSON is there. Now you can actually update it. You can insert it. You can modify any attribute there. Not only that, this is the funny thing. You can do search. Hey, I want to search for this attribute. It will actually do a very fast search. Yeah. Not only that, you can do star and fuzzy match search. You can do fuzzy match search also using this. You can create indexes also using this. So this has become pretty much similar to MongoDB. Like MongoDB does like a lot of these things. So now you can say what power it has got. In microsecond, you are able to solve this problem. So I can't do this also, but you got the idea. Yeah? Yeah? Huh? P99 performance. That's what it is. Like internet is not there. Well, I think I can get the internet from my phone. It's an international phone, but like let's see if I can get it. Personal hotspot. Yeah, let's see if I can build the personal hotspot. I can use this, which is fine. Yep, I think I can use this. Okay. Let's see if this works. Last time. Ooh, well, it's trying, it's connected. That's a good thing. That's promising, yeah? Okay, so I'm just going to go in here and then try it out using this particular server. So let me make it a little bit smaller here so to actually look at it. Okay, so let's go to the workbench. So you can go to the workbench here. You can go to the documents. Within the documents, working with JSON. Now what you can do is, this is the JSON it has got. You can actually execute this JSON and then create this JSON. So you're putting the JSON blob here. Okay, that's what you're trying to do. Once you add this JSON blob, it's actually going to the cloud. Well, the phone works. That's good. So now you can read the whole document. This is what I was talking about. Very, very powerful now. Now you can read a single property of the document. Are you guys able to see? Make it a little bit bigger here. So you can read this document. Now what you can do is you can read an element of that particular one. So you can get this element also. You can update it. Update is also possible. Similarly, you can delete the element and you can add an index also. You can also add an index to this particular property. And then once you add the index, now because the index is added, the advantage is that now you get the information for that index, which is really, really fast. Now I can do exact search. This is what I was talking about, nature. I want to search for the nature. Aha, it gave me 2 schools with the nature. You know, forest school and garden school it gave me. Return with certain fields. I want only with nature with certain fields. Wow, so fast. I'm able to get it. Fuzzy text search. Okay, fuzzy text search. Star. See this? I'm putting a star here. Star culture. I want star culture. Oh, I'm able to get the culture. One of the Guilford school is there with the culture data which is coming through for us. Make sense? Numeric range. I want to find from this to this. I want to find out all the students between this and this range. I got that value. Oh, tag. I have a tag. I want to search with the tag. So you can have geolocation coordinates also. So now geolocation also they added in this. So I'm like surprised, like this came in like in the last few years. And I'm like, you can do AND operation and OR operation. This is pretty very, very powerful for you to use. So good, the internet is working, guys. So we were able to fix the internet by using my mobile. So that's a good thing. Which is international plan. I didn't know that it will be that fast, which is good. So what that means is now another thing which came up was graph databases. Now graph databases is, why graph database is important? Neo4j is here, na? Yeah? So you guys have seen the demo, yeah? Yeah? So which is very, very powerful. Now the advantage of that is, now what we are doing is, you have a schema like this. You want to put this schema into a star schema first. That's number one. So you're going to ask me a question. First question you're going to ask me is that, hey, where should I put it? In SQL database or that database? What is your answer? Both. Both, na? So because you're going to put the same data here to do the analysis. What are the nodes closer to me? If you have a purpose-driven mode, in that case you can use that. For example, how many here saw like a talk where everybody is connected to everybody 6 down? Yes, somebody said like everybody is connected to everybody 6 leg down. Yeah, so there was everybody is connected. So that means that like you can find out how many people know this company where I need to apply for job. Ooh, you can do that where? In LinkedIn. You can actually go to the LinkedIn. If you get their pro version, I'm not getting anything like that, but LinkedIn using that same principle to do that analysis for us really, really fast. What are they using in that case? Graph database. Yeah. Neo4j is one database. There are other databases of graph. So what's really happening is, let's go to the graph databases. Yeah. So we are on the same page. So graph databases, when we are using, well, it will come, hopefully. Yeah, it's coming. It's a little slow, but it's okay. So graph databases are there. So Neo4j is one database, but that's not the only one. So we got like all the other databases are coming up. Now if you see here, Microsoft is multi-model. That means, see what they're doing is, Microsoft is doing is, and I'm not with Microsoft. So just telling you like, there's something which is happening. You see the trend going on? You see some trend? What is the trend? Multi-model support. And at the end, that's what I'm saying. So I'm not going to show you those slides. But this is saying is that Microsoft Azure Cosmos DB is doing document DB also, key value store also, white cloud. They're saying we're doing everything. Like, you pick and choose what you want to use. So Neptune, Amazon Neptune is there. Somebody was using Neptune here. So they're moving to another version, Neo4j, because this is more vendor provided version to use. So Neo4j really helps us like, create select query. Instead of like this query, we'll be able to get a graph and be able to process it really, really, really fast. So everybody use the movie one. Did you guys try this out? The movie one? No? Yes? Okay. Let's see here if I can find it. So Neo4j, let's see if I have it. Okay, Neo4j is here. So if you see here in the Neo4j, let me open this one, yeah. Okay, so this is all the movies which are there. But the main thing is what the strength of this is not just this one. The major strength is, which I really liked about this one is, it's not just the matching. Hey, I want to find out who's matching this. That is one way of looking at it. Who can introduce me to my new job which I need to go to? If you need to find out that kind of query where Tom Cruise with the co-actors who are working in different places. Tom Hanks and Tom Cruise never work together, yes? So if you need to find out who all are the co-actors they were working on, you can find that information here. But another one which was very interesting was, let me show you the interesting one, shortest path. See, this is the shortest path. How many here know about the shortest path? Shortest path is not just distance. Shortest path is also when I'm connecting from one dot to another dot, how much distance is there between them. This is called a shortest path between Kevin Bacon and Meg Ryan. Now what happens is, this is going to give us disjoint graphs. What is this called as a disjoint graphs? Why this is useful? Anyone? Now, you can go from any point to any point in this case. That's called a disjoint graph. Sometimes disjoint graph is used to find out whether there is any connection between them or not, or introduce a connection between two different people who are working on it. Make sense? So that's the reason we are using this for. And you can also go deep. Also, like you can do a lot of things in this one. Yeah. All right. So let me go back again to the slide deck now, because this is a good thing to understand. Twitter does that. Twitter is like the LinkedIn profile. Linked is there for that one. DynamoDB, I think I'm going to skip this because it is similar to the other model. Other databases, MongoDB, we all know JSON format is there. Now Sparkle used to be there, RDF is there, where you are creating your own taxonomy. If you are building your company's taxonomy, you need to use this. You can use this. The DBpedia uses this one, the same one. Gremlin is another one you can use. Time series is also really big, like it's coming up. How the data is moving over time, that's something you can use. RDF is another one you can use. Event store database is coming up. You're storing the events and you're processing the events at the same time. So that's where it's coming up really big. Okay, so now what I'm going to do is, I'm going to just go into the NoSQL database, because other things you all guys already know. So I'm just going to talk about for next 5 minutes NewSQL database. So why NewSQL database is coming up? Do you remember we were talking about third normal form? Then I told you don't use third normal form. In 5 years from now, I'm going to say use third normal form again. That is what is NewSQL is all about. What NewSQL is really providing as a SQL database, so MySQL database, or like any database there, how can you make it using the queries, using the hash table to really do that. NoSQL database has a drawback. You know what is the drawback? What is the biggest drawback of NoSQL database? Anyone? Huh? Reindexing. Reindexing the major drawback. That means if I add new things to it, it will reindex the whole thing. It creates the whole mess out of it. So how about I make it much more smarter, resharding the whole data, so it's picking something or the other for me. So how about we do one thing, we think of a different model using CockroachDB does that, and there are other ones which are coming in on this one. What they're doing is they're trying to create an abstraction layer now. What that abstraction layer means that A, B, C, D is there. You say A to B is in here, C to D is in here. If there is a E added, you're going to add after D. Yeah, so that's what the CockroachDB is adding. 0 to L, L to P, P to infinity. Now if I add something else on top of it, I'm just going to add it in one location itself. Melon and other things I'm adding. So I can actually ask for a query, I want from cherry to mango. Only that query is returned, which is in different segments for us. So it makes the indexing faster without resharding the data. The advantage of this is the splitting also becomes much easier. Now you can split the data and becomes much easier. So what they're saying is, with the consensus model, you can do actual transaction. Say that, hey, when I am saving the data, if it's not saved properly, if it's not showing in all the nodes, it is not there for us to use. That's the reason you can use CockroachDB to really solve this problem. What they're saying is you can actually do pinning of the data. How many here has data residency requirements? Yeah, you have used the CockroachDB? Yeah? So how is the performance of it? Huh? Gigabytes? Yuga, okay, good. New database, yeah. So that's something you can use. So you can do country pinning also, which is like a really good feature which I like about this. Now you can say US is separate and this is separate. The data will reside there only. And then you just do the country pinning and be able to do that kind of system. You can get all the ACID transactions. Whenever there is a transaction taking place, till the time the transaction is complete, it's not going to commit that particular transaction. So that's the advantage we have in that one when we are working on it. So that said, like I think we have few more minutes left. So I'm just going to take, because I promised one more thing. I think we have till 5:30, yes? Yeah? So we have time, yeah? That's what I thought. Somebody said 5 minutes there, so I was confused. Okay, that's good, that's good. Oh, you guys are fine now, because I want to complete the multi-tenant part, because if you want to look at it, yeah? Yeah? Okay, so multi-tenant, how do we do multi-tenant is very important. The point of the matter here is, like when you are building the system, you have healthcare system, you have analytics going on, SaaS is going on. How do I do for all the databases? Multi-tenant environment, that's the problem. So in that case, what you can do is, what you need to do is you need to create something called as a pod. You know what is a pod? Anyone? What is a pod? Huh? It's a container, yes? So that's why I'm saying pod, because it becomes much easier for people to relate to. But that pod has multiple co-located services, yes? That means all the microservices are located here, yeah? So what happens is that we need to make sure that this pod, when I say this is a pod, that means all these things is in one pod, from here till here, okay? Now, when I say blast radius, what does that blast radius means? Blast radius means that this thing goes down. This thing goes down. When this thing goes down, then the whole system I'm route 53, I'll not route the traffic to that, okay? So how can you say that this is going down? What you can do in route 53 I'm talking about, you can check for health check. You can do health check, which is running. Anybody does that? Health check, yeah? If you are doing the health check here, now what it is doing is, you see that, oh, the traffic is not moving in here. Now you route the traffic to this location. That's the way you contain the blast radius. You know, if you saw Mark's one, he was talking about testing of all the nodes. How do you do that? And this is the way you're going to do the actual testing of it. You can do deep check or health check, just the thing is there or not. Now the data is all residing in all the places, this thing which we are talking about here. Now, when you're trying to connect through that, you can have a pool of services together. You can have a silo pool or all the multi-tenant together. Yeah. So that means you have one database with all the tenants, or you have a government and you're supporting them like one database to do everything. Yeah. So when a request comes for a given tenant, you need an onboarding for that. Onboard a tenant and then remove the tenant at the end. Yeah. So that also you need to have. That means you need to do tenants consumption model. You need to know how much they're consuming in the database. You need to find out how much they're consuming. Based on that, you charge them the money. Charging the money means you're connecting through the JWT account, through the product service. Now you're sending it to S3 buckets. So this is a database. Yeah, this is a store in the database, which is log is tenant agnostic. That means you're putting a slash customer ID and then processing that value. Same thing is true with the Kinesis stream. Now you're sending it to the metrics. Now you're finding out how much money should I charge them. This is data partition. Which DynamoDB instance I need to connect to. This is the isolation. What information they have access to. That's the way we do the multi-tenant, do that. Now we are choosing, which one should I choose? Consistency, schema, processing, and storage. Which is the model going in? They're all combining. Consistency model is combining and all becoming embedded JSON. Wide columnar is also becoming embedded JSON. All the languages, they're supporting all the languages now. So all of them are coming in, and same thing is true with the RDBMS database. So that kind of completes the loop for us for today. Thank you.